Hello, Brian. We can't hear you. As we wait for the speaker, kindly you can type in the chat or open your mic and tell us what you've gained from the bootcamp so far from the 2 days we have had. Thank you. Anyone? Anyone? Thank you, team. We have learned about Git and GitHub usage. Anyone else?
Hello.
Hello, welcome back.
Thank you. You can now hear me. It was a small mic problem, but I'll be continuing with the presentation.
Right now, even you Balvin, to go for all election, go fast. Today, what?
I hope you can all see my screen.
Yes, I can see your screen on my side. I don't know about the others. Yes. Yes, Grace can see and Adam can see us.
Also, guys can see.
Yes, they can see.
Oh, yeah. Okay. So I'll be taking you through some simple syntax math operations which you can use to manipulate in your data set. Yeah, some of which are the addition, the subtraction, the multiplication, division, floor division, modulus. Yeah, so most of it is just direct Python language, which is just which is represented by some signs like the star for multiplication, the addition, the subtraction, the division, two hashes for floor division, and yeah, I've done some of the operations like the 4 asterisk 2, that's 4 power 2. 11 percentage 5, this shows like the remainder. In case 11 you divide it by 5, what the remainder will be. And the 11 hash 5, that means the 2, the number of 5s in the 11. So yeah, just some basic simple mathematic calculations. You can also be able to get out to pull out the maximum number in a list by just typing the max. And as you can see in this example, that I defined a list with x, which was max 15, 20, 43, 33, 43, and I was to print out the max, which, as you can see, generated the highest possible value. And we can also be able to find out the word with the string with the highest number representation, like A representing 1 and Z representing 26. And we can see that in this string, in this list, Valerie had the highest. And there's also some of them which you can also use the sum. The sum, yeah, we can define numbers in a list and just pull out the sum and it will just add it for us. So those are the basic math formulas that we have in Python, which are quite simple to say. And we also can create functions using it. Just create a function, define average AB. You just put numbers in a list and add 2 numbers, the ones that we defined over in our function as the input variables, then divide by 2, then return them as the numbers average. So as you can see in this example, average you took of 2 and 4, it returned an average value of 3 for the 2 numbers. Yeah, you can also use it to calculate, say, the circle area. Yeah, and we can use it to calculate the circle area just by inputting the radius. And yeah, by just putting the circle area, we can put values of radius, which is 4. We can define a function which is area is equals to 3.14 just by the normal mathematical function that we have been doing, and multiply it by the 4 times 4, and yeah, return the print of we return the area. That is just a simple mathematical formula that we can use to calculate. And guys, if you feel I'm hurrying or something that you need me to clarify, kindly just feel free to stop me and interject, and I'll explain it further. And there are also a number of libraries that we use in Python to help us in our analysis and mathematical. So most of them are the numpy, the pandas, and the matplotlib, which basically we can use it to try and manipulate variables, numbers and variables in a matrix, say in a data frame, or any kind of data that we have. So in this case, we use the numpy library to generate a sequence of random variables in a matrix using the randit library, piece of library that is in the numpy. And we generated them from 0 to 5, the size of 5 to 4, creating a matrix of 5 and 4. And as you can see, it created a matrix over here with numbers basically from 0 to 5, and it just generated a wholly new matrix. Yeah, so we can use it to generate new variables and new numbers according to the kind of distribution we want. And we can also describe it to generate uniform distribution variables, Poisson distribution variables. Those are all in statistics, but yeah, we'll see them as we go on along in the bootcamp later. Yeah, as we deal more into statistics. And yeah, and I'm not sure how you know how to create a data frame out of lists and a dictionary, because I created this data frame using a dictionary and defined groups from just random groups from 1 to just basically a number of groups and the values each of them contain. So I was trying to basically use pandas to generate a value count for how how each groups and how much they occur, you know. And as you can see, the value counts for group 2 were 3, yeah, just to try and count the number of and how the occurrences in the data frame. And as you can see, the group 2 occurred thrice, group 1 occurred thrice, group 5 occurred twice, group 3 occurred once, and group 4 occurred once. So this is just a basic mathematical formula, which is value counts. Yeah, just by defining the groups, the kind of variable that you want to extract from the data frame, we can actually count the number of and how much the number of occurrences of a particular group. So in this case, I was trying to count the number of groups, which is by this value counts. I'll be sharing the link to the collab notebooks if in case you need it for further analysis of trying to read it on your own. I also created another data frame and with a name, year, reports, and coverage, and created a new data frame with just to do more analysis and to show you how pandas can actually be a good analytical tool, a good mathematical analytical tool. So in this case, we can also use it to create what's the name? Yeah, we can also use it to create kind of forgotten the name, sorry. We can use it to create okay, in this case I was trying to come up with the coverage and just to filter out according to a stance that we want to create in the data frame, just to filter out values according to what we want. It's very common as you go to create a task and you're asked just give us, okay, maybe the areas that have coverage of more than 50, and as you can see here, you just create you create a function which a kind of an instance where you just want to filter out values which have more than 50, and you just define the column and the value that you want it to reach, and you and a list comes out with all of this which have more than 50. And as you can see, there was one that probably had a coverage of less than 25, but it wasn't really here as we tried to calculate our mathematical instance over here, and it was filtered out. We can also create two conditions. Condition was the word I was looking for. Condition, we can also create two conditions just to filter out according to two different columns. Say we want coverage of more than 50 and reports of less than 4 according to this data frame that we have collected. You can also just create a condition, two conditions, which also filters out from the main data frame. And as we can see, creation Eldoret had a coverage of more than 50 and a reports of less than 4. So this is just basic this also mathematical kind of calculations that you may be required, or conditions that you may be required to use in your data analysis or in your data science career as well. And we can also creating a different data frame. There's a function in Python called as lambda. I don't know how many of you guys have come across it. Lambda is a function that is created in like a very small in a very small context, just to filter out according to a specific, just a small kind of condition, or whatever that you're trying to create. It's like a mini function, like the def one, the one that you create the def, then put your variables in it. So in this case, lambda is used to just to create a very small function to use in only one instance. So in this case, I created a function called lambda country, just to pick the rows that have Syria in the column country. And as you can see, you have to use the map function and the lambda, then you just put some columns and you describe, okay, I want Syria in the country, and you can almost filter out. And this is just a case of 2 rows. You can have like 1,000 or 2,000 rows, and you really don't have the time to go picking out in each, where Syria is probably in the in the country column. So this might be a very good and might come in handy just to try and filter out any kind of any kind of word or number. It's not only used for string, you can also use it as a number. Say lambda coverage, then in lambda coverage in then you describe the kind of value that you want, maybe 62 or 70, then in this particular coverage here. Yeah. So guys, do you have any questions? Hello? You good? Okay, none so far. What's coverage data frame? Oh, okay. This is just a data frame that I've created. It's a data frame which I created with a dictionary. The dictionary starts over here, where you can see the curly brackets here, and it ends over here. So I created a column name with a name, the year, the reports, and the coverage. Yeah. So this was just to create this data frame over here, this small data frame over here. So in this case, I was just trying to illustrate how you can create conditions and filter out them in say an instance, even in a larger data frame, because these are small one with around 5 rows. Yeah. So, but in a case you might be required also, you can have a data frame of 1,000 rows, and you just want to filter out those with a particular number or less than 50, or yeah. So coverage is just a column in this small data frame that I have created. I hope I've answered your question.
Yes.
Okay, so I'll be heading over to a bit of descriptive statistics. I presume most of you have come across any kind of measures of central tendency. Those are, don't be frightened by measures of central tendency. It's basically the mean, the median, the mode, and yeah, some skewness, kurtosis. Yeah, just to try and find out how your data looks like, just some basic kind of statistics, just to yeah, basic kind of statistics, just to describe what you have in the data, not to try and improve. And I have a link over here, which, let me just send it to the main chat. It's a good read on descriptive and inferential statistics, but I'll also be going through it. Yeah, so yeah, descriptive statistics is a statistics or a measure that describes the data, just basically to describe what we have in the data. Yeah. And inferential statistics is using a random sample of data taken from a population to describe and make inferences about the population, is called inferential statistics. So in case of the in the inferential statistics, it's a case whereby, say, we have seen how InfoTrack, or you've heard of surveys where people go and you hear, probably in a political election, that such and such a person is leading, say, in a survey or something. A certain leader is second on certain InfoTrack poll. They don't really go to each and every person as it is in an election day just to try and come up with the results. They have to take like a small pilot program of, say, maybe 1 million people, or maybe 500,000 people, or even 100,000 people, so that they can use it to describe the whole population and the whole country of how it deserves. and how they decide and what the current mood is on. Yeah. So that's what is basically called inferential statistics. You're just trying to take a small piece of data just to explain the whole kind of scenario that you have, and it's usually generally true, and it works a lot. So you might have 100 people and just pick 10 people from a class randomly, and you basically explain what the class feels like. Yeah. But depending on the kind of sampling method that is used, there are a number of sampling methods that are used. Say random sampling, there's the stratified sampling, where you have to the random sampling you just choose without any kind of bias. Yeah, there's no, with a person who has not seen the group, a teacher can't do that because anajua kila mtu. So probably just a person who is just from nowhere, pick 10 people. There's the kind of different sampling, the stratified, you just pick according to, you list people in a number, like say 1 to 100, and you decide you'll be picking number 10, 20, 30, 40, 50, and you have described like the whole group. Yeah. So descriptive statistics, yeah, they're the common measures of central tendency and the measures of dispersion of variability. So the measures of central tendency include the mean, the median, the mode, the measures of dispersion of variability, the absolute deviation of the mean, the variance, the standard deviation, the range, the quartiles, the skewness, the kurtosis. Yeah, just to show how whether to know whether our data is false in a normal distribution, or if there are any presence of outliers, or which kind of distribution it comes along to, which will also help in the final way of trying to choose the machine learning algorithm that you're going to be using. So in this case, I created a data frame with a small kind of with also a few number of rows, and yeah, the basic kind of analysis was finding the sum, finding the mean, and just by the mean, yeah, it's the simple Pythonic language. It's just df, the column according to how you've called it, the brackets, the square brackets with the pretest score, dot mean, yeah, and you get the mean. Yeah, there's the cumulative sum, there's the description, just the describe, describes the count, the mean, the standard deviation, the minimum, the quartiles in our data set, and the maximum value. There is also the count. You can also find the mean just by describing the particular row that the particular column that you want. Mean, max, median, variance, standard deviation. Also find the correlation. Correlation is a value that shows the strength and direction of how two variables are related. Yeah. So in this case, we can see like the age and the pretest score have a negative correlation of negative 0.1. So it shows it's kind of a weak relation, a weak negative relation. Maybe the increase in age leads to a decrease in the pretest score, or an increase in the pretest score leads to decrease in the age. Yeah. And there's also the post score versus the age. There is a positive correlation in the positive direction. So an increase in the age also leads to an increase in the post score. So that's how it works with the correlation. And yeah, and we can also be using it to also kind of group our our data according to the different kind of ways that we want it. In this case, you might have data. Say, for instance, this is also a dictionary that I created with 5 columns, which are the regiment, the company, the name, the pretest score, and the post-test score. So in this case, these 2 variables, these 2 columns are not, yeah, they are string variables. They are not numbers like the pretest score and the post-test score. So these are kind of groups that we have. Say we have say during games we have like a team that is associated maybe with Man U or Chelsea, just two kind of variables that are two kind of roles that just describe which are the affiliation, the regiment maybe, and the company that each of them fall under. Yeah, so you might be under Nighthawks in the first company, Nighthawks in the second company. Yeah, so they're just trying to, these are two different columns that just describe which particular affiliation these people were in. Yeah, so in the Nighthawks and the company, which was the first, the name was Miller. This person had pre-test score of 4 and a post-test score of 25. Yeah, so we can also decide to group by them and to find out how each of them performed. Yeah, so in this case, this was a description just to find the pre-test score according to the regiment. So in the regiment, we only had the Nighthawks, Dragons, and the Scouts. Yeah, so we can find out we can find out what was their mean for each particular regiment. The Dragoons mean was 15.5, Nighthawks mean was 15.25, the Scouts mean was 2.5, and we all have their basic statistics over here: the standard deviation, the mean, the 25% quartile, 50% quartile, the 75% quartile, and the maximum number. And this can also happen in you can also group them according to the regiment and the company, the pre-test score according to the regiment and the company. So where you find the Dragons, the first company and the second company, you can have their classified means according to each and every place. The Nighthawks, the first, the second one, the Scouts, the first and the second one, 2.5, 2.5. Yeah, I'll be sharing this link to this collab with you guys. So yeah, don't worry how you're supposed to grasp all the codes in this. Yeah. So an important library also for mathematical display is the matplotlib, where we just it's a good visualization tool to just try and visualize what we have in the data. Yeah, just to find the kind of how much they seem, instead of just looking at numbers. You know, sometimes numbers can be tiring. Just looking at numbers, okay, these guys had a mean of this, and this was their representation. It's very tiring to look at it. So yeah, we can use matplotlib, and there's also Seaborn. Seaborn was also under the same structure of matplotlib, but at least it's an improvement to visualize things better. So in this case, we can try and we can visualize a bar plot with two kind of with only we can visualize this lists which we define them as: the first one was the nuclear, which represented for the 5, the hydro represented the 6, gas the 15, oil the 24, coal the 24, biofuel the 8. Yeah, so we can try and see nuclear, can say where it was. The hydro, the highest, you can almost see it's coal, then oil, then gas, then biofuel, hydro, then nuclear. So these are a bit simple to visualize. Yeah, to see which stood out instead of looking at numbers. So and there's also the visualization by the histograms. Histograms are very popular just to see the distribution of the data which it falls into, and as you can see, these are kind of unimodal or bimodal because of this. Yeah, they are popular just to try and find out the distribution of what our data looks like. You can see it's almost 1 point, which is, this was the highest, which is about from 40 to 60. Yeah, and also the one at the end over here at 120. Yeah, you'll have this codes, don't worry. We'll have to, and you can also do more in-depth analysis just by googling matplotlib as well, and try to find out the matplotlib visualizations, invariant visualizations, basic descriptive statistics, and you'll find a whole lot of load in kind of visualization somebody can do. This is just a few kind of visualization somebody can actually see their data in. And yeah, there's also pie charts. You can also use pie charts to visualize our data. And yeah, in this case we visualized yeah, you can see I try to visualize the Python and yeah, the different kind of languages, all of them, and you can see their percentages, individual percentages in each and every particular one of them. Yeah, Python had 26.9%, Ruby had 30.6, Java 26.2, 16.2. Yeah. And finally, we have the box plot. A box plot is generally used to visualize if the data we have has any outliers, any kind of funny identification. Say we have a column with a column, say we have weight for class 3 pupils, and probably there's 30, 40, 50, and there's one no, not 50. Class 3 people can't have 50 kgs. It was, yeah, maybe that's the outlier. The 50 kg as the outlier, and most of them are between the 30 to 40 or 25 to 35. Yeah, so you just try and see, okay, which is the most. They usually show up like some dots coming over to the close. In this particular column, there were not really any outliers, but with outliers you can almost see them at the far end in this. Yeah, so I think that's it for any kind of basic math. You guys, we'll be going over with more statistics and jumping over to the inferential statistics as you dive deeper into the understanding of the statistics itself, do a few tests of hypotheses, and yeah, so we can finally come into the Python application for the inferential statistics. But for basic math, by grouping and pie charts and histograms and bar plots, any kind of grouping just to find the means for each particular group, this is all for today. If you guys have any question, can kindly pop them up. If any place that you didn't understand, probably it was too fast, or yeah, or I didn't illustrate it clearly. Hello. Oh, I sent the notebook. Okay. Let me just send you the notebook. Hello, anyone with a question? No, not really, Alvin. No, Matplotlib is just a visualization tool. Yeah, they don't use to show it. Or what did you mean to show us the election percentages? It's basically a test, a survey, just to see the preferences of each and every person. So yeah, they might be they using Matplotlib just to show the bar plots of each and every person. Yeah, but no, can you kindly come clearly with that question? I'm not really aware of how to answer you. Alvin Battle. Hello.
Yes, hello. I was just thinking of it as an example. Like, do they use it, like, to show us the election details, like, in case, like, specifically for one, or they use protect?
Okay, I don't know whether Alvin is around. King Bugwe Roni is asking how outliers handled. In some cases, they are dropped. Yeah, they are dropped because it may distort the machine learning algorithm, but it depends with the decision the data analyst will have to might decide to bring forth, because um in some cases they are reasonable. Say you're analyzing house prices of a particular company, and some houses are in Karen and some are in yeah, some maybe cheap place to some place that is a bit mwananchi kawaida, yeah. So you'll always have the outliers that people are living, yeah, them 100 million houses, and there are some which are 5 million houses. So sometimes it's justifiable to keep the outliers and not to drop them, but in some cases it's really not it's really not supposed to be there. Say in a case where maybe it's the weight of children, and one kid is totally alone, yeah, or 30 kg, 40, and the others are between 10 and 20, and it's only one person. So in that case, you drop. But if there are many, you can keep them. I hope I answered your question, Kimbugwe.
Yeah, hello. Hello.
Hello, yes.
I was asking, what's the difference between numpy, pandas, matplotlib, and seaborn?
Oh, inquiring, showing election percentages is an example Matplot can do. Yeah, you can show the election percentages as long as you have the data. You can show it using Matplotlib. Atieni is asking whether have any difference between NumPy, pandas, and seaborn. Yeah, NumPy, pandas, and seaborn, they're totally three different languages, three different libraries that are to their own specification. They have their own kind of job that each particular library does. Any they have their own jobs, particularly which are best for them, you know. So NumPy is basically for lists. Just if you want to manipulate any kind of lists, and just single number arrays, just arrays, and series variables. NumPy is very good at that. Hello, can you hear me?
You are breaking from when you began explaining the difference.
Am I still breaking?
You're more audible. Yeah.
Hello, Winnie.
Hello, yes, you're more audible.
Guys, am I breaking? Oh, okay. So yeah, NumPy, pandas, and seaborn each have their each particular task they can do. Yeah. So numpy is basically to deal with series and the kind of lists, and yeah. So, and pandas is basically a data analytic tool. It's a very powerful data analytic tool in the sense of it's more powerful to manipulate data frames more than numpy can do and more than Seaborn can do, you know. So but so it's basically, and as we've seen, it's most likely used to show basic descriptive statistics and group by data frames, where we can basically see results of each and every, how we love to segment each particular row if you wish to. So pandas is more of a data analytic tool. It's a very powerful data analytic tool, while Seaborn is a tool we is more powerful in visualizations. The kind of visualization pandas can do, not Seaborn is more powerful than that. So they have it's part of a big engine to just make data analysis and data science more better. Yeah, like sklearn is good for machine learning, which we cannot use also in data analysis. So yeah, those are 3 different kind of libraries that, yeah, we just use them for the bigger engine, yeah, for the bigger data science goal. Any code on how you can separate outliers? Yeah, there are many kind of codes that you can use to separate outliers. They are not usually the same. There are different ways that you can actually remove outliers by. Is the z-score, where you can basically calculate just to find out if there are any values overstretching more than a particular score that you set, then you can drop the outliers. Yeah, but you can, Kimbugwe, I'm challenging you. Just Google. It's basically code. The good thing about this science is, as long as you know that you're supposed to drop outliers, the code is easily available everywhere. So you can just Google any kind of dropping outliers in Python, and you'll find a whole kind of websites. But there are so many codes for that. I have no really particular code on how to drop outliers. Okay, you're welcome. Anyone who has a question? Before I hand it over back. There's one guy who has decided to share us. I don't know whether Winnie is in the team, in the call, but we can just see if there are no other questions.